Hello guys, welcome back. So in this video, we're going to create a simple application which is going to help us to restore and save the states across configuration changes without using a view model. So without further ado, let's get started. Okay, now for demonstration purpose, we are going to create here a account application which is going to help us to demonstrate how we can save and restore states. So for the first time, we can just create here a new composable, and then we are going to call this counter. And here we're going to create a counter state, and we can use hereby, and we can keep here the user state by remember. And here we can use a mutable state of. Now for that case here, we're going to create a simple application, and this one is going to be situated inside a row. So we can create here a row. Now we want to pass in here the minus sign, but this one is not available using these icons image vectors. So what we can do here, we can come to resource manager here and click this button here and click add here a vector, and we can add this minus sign here and click next, and we can click finish. Now after that, we have this icon baseline remove, and we can use a painter resource. Now for that case here, our application is ready, and what we have to do here now, we want to reassign here our counter. Okay, now we can open this project here, and we can come here to this main activity, and inside this main activity here, we can change the scripting here, and we can call here our component, which is called counter component. So for that case, we can try to run now our application. Okay, now our app is launched, and we have here a plus button and a minus button. So when we try to plus here, it's going to add here. And also when we try to minus here, it's going to decrease by 1. So now let's try and rotate here our device to perform a configuration change. And as you can see here, the value is going to decrease back to 0. So the state is going to be reinitialized. Now for that case, also when we try to rotate our device, we are losing our state. So what we should do here, we can try to use a view model, but a view model is not suitable for this case, because for example, when we want only our state to survive the life cycle of a composable. So using a view model is going to hook up until the view model is being killed, and the view model is going to be cleared when the activity which uses it's going to be cleared. So that's not going to be the case for now. For us, we want to just kill this when the composable has been removed or has been cleaned. So what we have to do here, we can try to use something which is called remember savable, and this remember savable is going to help us to save across configuration changes or process this or activity recreation. So it uses the same way as how it used to save the instant state to save this state here. So what we can try and do here, we can try to just change this here and use remember. Now, when we come here and press Ctrl Q, you can see that we have several parameters which we can try to pass inside here. And you can see here it behaves similarly to remember, but stores the value will survive the activity or process recreation using the save the instant state mechanism. So we have here a input, which is the set of inputs, so that when any of them has changed, will cause the state to reset. And the saver object which defines how the state is saved and restored. So we have something which is going to define how we can save and restore. And also we have a key which is going to be differentiating between this remember savable inside the composable tree. And we have here the init factory, which we are going to pass in here our state value. And this one is going to be called every time when we want to recompose. So here the very important thing which we have to keep in eye, so this saver here. So as you can see here, when we come here and press Ctrl Q, we can then press Ctrl click this. You can see it's going to take up to where it's been declared. And you can come here, you can see it's using an autosaver. So this autosaver does not provide any conversion. So this one, anything, for example, anything which can be saved inside the bundle can be saved automatically. That's why we're using here an autosaver. So for that case, we can just come here, and we don't want to provide because we're using here an int which can be easily saved inside the bundle. So what we can do here, we can try to rerun our application and see if this one is going to survive configuration changes. Okay, now our app is launched. So let's try here and add here values, and we can try now to rotate our device and see if the state is going to be lost. So as you can see here, the state is being served across configuration changes. Now, for example, if you have an object which cannot easily be added to a bundle, what can you do? So let's see, for example, if we create an object that is going to store this counter and see how we can do this. Okay, now we can try to collapse this here, and we can create here a data class. This one is going to be of type int. Now we want to create this to be our safety state. Now for our case here, we can pass in here our count. And yeah. Now after that here, now we can fix this count because this one is going to be, we can pass in here a counter. Now, for that case here, we can try and run our application and see. Okay, now trying to run our application, we are getting this error. And as you can see here, we cannot, the mutable state containing counter cannot be saved using the current savable state strategy. So for this case here, now we have to provide a custom implementation. So the easiest solution for this, we can try to make this passable. So for example here, you can just add passable implementation, and now you can try to run the application, and this one is going to succeed. Alright, now our app is launched. And as you can see here, we can do as usual because it has succeeded, and it can save its state whenever we refresh the device. So this was not a good implementation of using this counter here and passing here passable. So there is a neater way or cleaner way to do this. So we can try and do this right now here. Okay, now here we can try and remove this here passable implementation, and we can create here another variable. So this variable is going to map up the saver and create as a way which it can easily convert the counter class to what can be easily saved inside the bundle. And for this case here, now we can create, for example, here we can call this counter saver. And this one we can try to use. So there are two implementations here of saver class which can easily be used. So we have a map and the list saver. So for example, here we can have so we can write here on, for example, first. So here we have our counter, and what here we can use a map saver. So if you come here to this map server, you can press Ctrl Q. You can see that this map server here is going to implement this server class here, and which is allow us to represent your class as map of values, which can be saved individually. So if you have several things which you want to save them, so you can try and use this map server and save those keys when the activity has been recreated. So what we have to do here now is that there is two functions or two parameters which you can use. So we have here first, which is called save. So here we can come and provide the conversion. So this save here is going to provide the conversion. And if this one is going to be null, it's not going to perform anything. So it's going to return the value. And also here we have the restore value. So inside here now we can try to restore our values. So if the value is going to be null, it's going to reinitialize the whole application or the whole state so that we can take the value. So for this case here now we want to say, for example, here our counter. Now we want to return here a counter, and what we can do here now, we can pass in the key which we have. So here we have a parameter. So okay, now here we are performing conversion. So we are going to set this as the map, and we're providing here a key and here the value. And here we are restoring the value back to this counter. So what we can do here now, insert this remember servable here. And basically there we have finished, and it's really easy. So Jetpack Compose makes everything easy. So you're just performing here conversion, here you're restoring the value, and here you're just passing the custom server as a parameter. Now let's try and run our application and see if it's work. Okay, now the app is launched again, and when we click here, it's going to add these values, and let's try and rotate our device. And the state has been saved. Now, as you can see here, we are using a map. So what if you have a lot of values, so you have to define a lot of keys so that you can restore these states. So instead, you can try to use a list server that is going to add them inside the list. So let's do this here. Okay, now what we can do here, we can try to create another data class for demonstration purpose to how we can use a list server. So here we had a map server, which we had to define keys in order to set this. So we can set this by using a list and not define a lot of keys. So this one is going to be, for example, you have here let's create here data class, and here we are going to call this size, for example, and this one is going to have a variable, and this one is going to be of type int, and also we have another variable which is going to be y of type int. So for example, here you have a data class, and this is usually you have data class that has a lot of variables. So in order to use this map server here, you have to define a lot of keys in order to save it. Now, for example, here we have only to use a list server, and it's going to save us a lot of time. And let's create here another variable, and let's call this size. And here you can use this list. Okay, so here we're using a list server. So here we can define here a servable class, and also we can provide here original class. So our original class here is going to be size, and our servable, we are going to set this as int. So what we can do here now, we can pass in here our servable class, which is going to be size. And also here we can provide here as int. So we want to set this as int and as servable. And also as the map server here, we have two parameter, which we have the save lambda function here, which we can use to send this. So for example, here now we can pass this to be size. Okay, now what we can do here, we can save this as a list of, and here you can pass in size.x and here size.y, for example. So we are adding those two variables, and what we can do here now, also we can pass in here the restore function, and we can use this lambda function here to restore our values. And as you have seen here, we have a list of int. Now what we can do here, we can create a size, and here we can use this int. And instead of passing here keys and other things, we're just going to use this 0 here, and here we know that it's going to be the second. So this one has saved us to create variables, and saving is, so don't get confused that you're going to save a list here. We are saving here a single object inside this, and here you have to use a mutable state of in order to set this, for example, to use this counter. So for example, if we remove this counter here and we use here size saver, and instead here now you have to use that, and you're going to go. So that was just for demonstration purpose. We're not going to change this. So I was showing you how you can try and change this and save them inside your application and use this list saver to save you a lot of time. Now, for example, here, let's try to create another example, which we are going to use a mutable state list of, so that we can use a list and how we can save a list and restore a list inside here. Let's do this right now here. Okay, now here we are going to create a variable, and this one we are going to call it nodes, for example, here. And here you want to pass in a mutable state list of and this you want to be a mutable state list of a string, so that we can create here a string. So for demonstration purpose, we can use here a scaffold, and here we can provide a floating action button. And okay, and here we can use a lazy column. Okay, so everything we are going to display inside a lazy column, and here we are providing a floating action button. So we want to click here and add several data which are going to be used using this mutable state list. So let's create here a function. So basically here we have several strings which you want to return, and we're going to return a random strings. Okay, now what we want to do here is this floating action button here. We can call our nodes, and we can call this nodes.add. And basically here what we want to add, we can get the random nodes. And we can try to add now. Okay, now we can change here. So our UI is ready here. We can come here to this nodes component and come to the main activity. Instead of this counter component, we can pass in here the nodes. Works component. Now let's try and run our application and see the output. Okay, so the application here brings us an error, and you can see here the snapshot state list cannot be saved using the current savable strategy. So this means it cannot be added to the bundle. So what you can do is create here a custom saver. So instead of using the list saver or map saver, let's create our own saver here for this case. Now let's come here and create another variable. And we're going to call this saver here. And what we can do here, we can use the save. And now we can try to pass in here the original and savable class. So the original class here, we want to set this to be a mutable state list. And what we want to save here to be a savable, so you want to save this as a list. And to do this, we can pass in here a list or string. And as usual here, we have two functions here, and we have the save lambda function, and here we can try to save. So what we have here, it is, we can convert this to a list, as you guessed. And also here we can pass in the restore. And here now we can use the list which is provided here, and we can convert this to mutable state list. And here we're going to get up a snapshot. And for that case here, now we can come here to our remember savable, and we can pass in here our server, which we have created. So here we can use this server and pass in here our server, so that we can define and not use a state server for this case here. Now let's try and run our application and see if this is going to launch. Now the app has launched successfully. Let's try and click this floating action button here to add new values. And as you can see here now, it's responding and it's going to add these values, which we're going to add here. And now let's try and rotate our application and see if the state is going to survive configuration changes. And yes, indeed it does. So we have used here the remember savable in order to save these states. And also we can try to, when the composable is going to be killed, these states are also going to be destroyed. So we don't have an outdated state when we kill this composable here. So guys, using states in Composable is easier, but when there is a lot of state, management becomes complex. So to manage a Composable becomes really difficult. So to solve this problem, you can use a state holder to manage state and UI behavior. So for now, let's leave it here. See you in the next video.